Chapter 22, here I want to talk about the heat engine. Heat engine, entropy, and the second law of thermodynamics. You know, in the last chapter, we talked about the first law of thermodynamics, and you uh, you have a relation between the internal energy of the system, delta E, which is equal to Q, a quantity of heat lost or gained by the system, Q hot or Q cold, minus the quantity of work applied on the system or provided by the system. Okay, you have omega, it can be positive or negative. When we have a increased volume, in the case of increasing the volume, omega is positive. In the case of decreasing the volume, omega is negative. So, in general, you had some idea about the conservation of energy of any process, of any cycle. Okay, just we were talking about the conservation of energy of any process of any cycle, but we did not study the conditions govern these processes. For example, you have some processes can take place spontaneously in the nature, and you have some other processes cannot take place spontaneously in the nature. What are the conditions for each one? Here in the second law of thermodynamics, you have to know the conditions for each process. What are the possible and impossible processes? Okay, because in the case of real processes, all the transformations are irreversible. It means you go from the initial state to the final state naturally, but you cannot go back with the same manner. Okay, in order to go back to the initial state, you must have an external agent, an external conditions added to the system. But in the case of ideal case, for example, you have a high efficiency. What I mean by high efficiency, it means when you give a quantity of heat to the system, in general, you must have a quantity of Q cold lost by the system and a quantity of work omega, because you know for any cycle delta internal energy equal to 0. So just we have a relation between delta E equals to Q minus omega. For any cycle, delta E equals to 0. So Q equals to omega. And the Q here, you have Q cold and you have Q hot, where Q equals to Q hot plus Q cold equals to the total work of the cycle. As Q cold is a negative value, you can say here absolute value and we can put minus. Okay, so here you can say Q hot equals to the work of the cycle plus Q cold. So Q hot added to the system will be divided as quantity, as energy, between Q cold lost by the system and omega is the work applied by the gas. Okay, the aim of the objective here, the goal is to increase the value of the work. It's a useful quantity, and we decrease the quantity of Q cold lost by the system. Okay, because Q cold is it's not a useful quantity. If you have a large quantity of Q cold, it means we have a low efficiency of any cycle. Okay, if we have a low value of Q cold, so we have a high efficiency. Okay, so here we have a balance between the Q added gained by the system and Q lost by the system, Q hot and Q cold. So here in the second law of thermodynamics, we have to understand all these conditions, the efficiency. Also, you must have some idea about the highest efficiency cycle. You have one ideal cycle where the efficiency is very high, and some other conditions. The second law also gives us some idea about the direction of any process, and I repeat again about the possible and non-possible or impossible processes. Okay, before